Today's lesson is lesson 2.2, Evaluating Functions Using Function Notation. Remember in our last lesson, we learned that a function is a relation in which each domain value, our x's, correspond with exactly one range value, our y values. In today's lesson, we're going to learn about something called function notation. Function notation is a mathematical notation that describes a specific function. Functions are named with letters such as F or G or C, as you can see right here in the table, and they indicate the independent variable, our domain values, and our input inside the parentheses. So notice here in our function notation, which is read f of x, our function's name is f, and our input values, our domain, are x, just like they always have been. And our range values are simply changing from y to f of x, because f of x, the function notation, is just replacing our y value. Notice here, h of t, our function is called h. Our input values, our domain, are t. They're just being replacing the x with t. And of course, y is being replaced with h of t. And our last one, our function notation is c of n. Our function's name is c. Its domain's values are n, which are just replacing our x values, and our y values are being replaced by the function notation c of n. For example, we do have a function called y equals 2x minus 4. It can be expressed in function notation as well. What I want you to notice is really the only thing that's changing here in the table is that the variable y is changing to the f of x function notation. Same thing with the graph. Notice the only thing is changing is the way that I name my function. Here I have to put the whole equation. Here I can just simply put f of x, the function notation, and I don't have to put the full name. I can also drop the of x part and just have the f. This comes in handy for geometry, because in geometry you're going to see lines with lowercase letters next to them like this, naming the line. All right, let's go ahead and try this first example. The equation y equals 0.85x represents a function. Go ahead and rewrite it in function notation. Now, I want you to use the name of your function as the first letter of your first name. So mine would be p of x, because my first name starts with p, and then the function itself would remain the same, 0.85x. Go ahead and pause the video and do the try this. And if you have any questions about it, please come and see me during class. Let's go ahead and take a look at example 2. We're going to go ahead and rewrite these equations below using function notation. But first, we have to make sure that we isolate the dependent variable y before rewriting if necessary. And we're going to write all of our functions as f of x. We're going to use f of x for all of them. And our second function is g of x, and our third function is, okay. So our first a is going to be f of x, and then we're going to go ahead and do g of x, and then we're going to go ahead and do h of x. So let me just go ahead and put these colors right here so that I make sure to use the same, the right letter. Okay, so let's go ahead and draw our lines, because we have to make sure that the y value is alone, because we do need it to say y equals before we can go ahead and write it in function notation. Now I'm noticing that there's a minus in front of this y and a 1/4 x. The first thing I move is the x. Always, always, always. The x has to go first. It is positive 1/4 x, so I'm going to go ahead and subtract it to the other side. Now, as I'm doing this, I can see that it does cancel, right? Because that is 0. That's the whole point of moving it to the other side. But before I stop right here, I need to pause and say, can I actually subtract? Can I do 6 minus 1/4 and say 5 3/4? I cannot do that because the 6 does not have an x and the 1/4 does. So I simply can write it as 6 minus 1/4 x. Now it does appear that my y is alone, but there is that minus in front of it. Whenever there's a minus in front of a y, that is a -1 being hidden in front of a y value. And in between them, we are hiding a multiplication of a -1. So to get rid of it, I'm going to go ahead and divide. Everybody's going to get divided by -1. Minus and minus would make a plus, right? Minus and minus would make a plus, and there is my equation. Yep, I've run out of room, so I'm going to go ahead and put it up here. And I could go ahead and move it around to put the x first and then -6. All right, let's go ahead and see if this one is a little bit easier. My line went all crazy. There we go. All right, remember, take the time to make sure you're solving for y. I only see an 8. I don't see the x with this one. So all I have to remember is how do I get rid of an 8? And how do I get rid of an 8 when it's in front of a variable, a letter like y? Remember, multiplication is hiding in there, so I'm simply going to go ahead and divide. If I divide to make it say y equals, I must divide each part by 8 on the other side, each part by the same thing. So that would give me 3x minus 10, nope, just 10. And there it is, and I'm going to go ahead and use g of x. G of x equals 3x minus 10. There we go. And for our final one, pause and give it a try. Go ahead and pause the video and give this last one a try. I see a 2 and I see a minus with that y. I must move the 2 first because anything that's in front of that y or behind that y that's not attached to it has to go first. So I'm going to move that 2. I cannot subtract it from the 9 because the 9 has an x and the 2 does not. I have to remind myself it is that -1 once again. So I'm going to divide everybody by -1, giving me positive 9x plus 2 because of the double negative. Minus, minus, and then of course the minus there as well. There's my equation. I'm going to go ahead and call it h of x equals 9x plus 2. All right. Since function notation relates the input and output of a function rule, it can be used to indicate how to evaluate functions. That doesn't look right because it's not. Evaluate. There we go. Let's go ahead and look at an example of how we would evaluate. Here is our function, g of x equals 5x minus 2, and they're asking us what is the value of g of 9. Remember, the parenthesis just means you read g of 6. You just read it as g and the parentheses instead of parentheses of. So they want us to find where the value of g at x is equal to 6. So all we're simply going to do is take this number right here and we're going to substitute it in for the variable x right there because it is taking place of the x right here in the function name. So we're going to go ahead and say 5 times 6 minus 2. Well, 5 times 6 is 30, minus 2 would be 28. So my answer, by simplifying, is simply 28. Let's go ahead and practice. All right, so P of n equals 1/2 times the quantity n minus 5 squared. What is the value of P of 9? I can go ahead and I'm going to go ahead and write it down. And then for this one, I'm going to go ahead and grab my calculator. Now I will admit I did the last one in my head and it was very easy to do. But this one, I'm going to go ahead and grab my calculator, and my answer is 8. F of x is equal to 7 times the quantity, 3 minus x. What is the value of f of negative 2? This simply means that we're going to replace x. We're going to replace x with negative 2. We're going to replace n with 9. That's all this one meant. That's all that meant. So 3 minus negative 2. I'm going to go ahead and place this in my calculator. And yes, I can either leave the double negative or I can fix the double negative and put 3 plus 2. Either way, I'm going to get 35 for an answer. Go ahead and pause the video and see if you can do the last one on your own. I'm simply going to replace the variable t with the number 10. I'm simply going to replace the variable t with the number 10. And then I'm going to go ahead and I'm going to pop this right into my calculator to get my answer. There we go. We can go ahead and evaluate our functions using multiple representations. We can evaluate our functions based on a mapping and a graph and a set of ordered pairs and a table. Um, in this chart, in this table, they have showed you various functions represented below. Like I said, the mapping, the graph, the set of ordered pairs, and the table. And each of them is showing you how to find the value of f of 2. So notice that we are once again, we're finding that we're given the x value, we're given the x value of positive 2. And we're finding that in the given function. Now I'm going to leave the graph for last, but what I want to show you is that right here where x is 2 is where you can find your answer. Notice on all three of these, our answer is our y value. Notice on all three of these, our answer is our y value, because that's basically what they're asking us to find. Remember, f of x replaces y, and so when I put in f of 2, I'm asking you find me y when x equals 2. Substitute it in. Now let's take a look at the graph. Our answer is of course right here. This is our answer. Now it seems kind of silly, so let me go ahead and zoom in just a bit on this one so that we can see it a little bit better. I first need to find x equals 2. X equals 2 right here. Once I find x equals 2, I need to go ahead and I need to move in an upwards or downwards motion to the graph. In this case, I'm going to go down to this point right here because this is my answer, okay? All right, now the answer to my question is, of course, y. The answer to my question is y. And I need to find my answer here on the y-axis. To get to the y-axis from this point, I need to move to the left or to the right. To the left or to the right. In one of these directions, I would find the y-axis. In this case, I am going to go ahead and I'm going to move to the left. And this right here, this number right here is my answer. So my answer is actually this number right here, but it is the y point of that ordered pair. If I were to look at this right here, it would be 2 comma negative 2, and my answer, when it's 2, my answer would be negative 2, right? The graphs are the hardest ones. Let's go ahead and practice. In the last example below, we are going to see the 4 representations: the table, the graph, the set of ordered pairs and the mapping. We're going to be asked to find f of negative 3. F of negative 3 is what they're asking us to find. Now, you could very easily go ahead and do A, B, and D. A, B, and D are pretty easy and straightforward to find. Remember, you're finding where x is negative 3, and then the y value is your answer. So I'm going to go ahead and just kind of slowly go through these. See if you can find the answer for C and D for me. All right, I hope you went ahead and found these answers right here. Oops, that didn't work out so great. Nope. There we go. I'm going to just not get a chance at anymore. Hopefully for this first one, you did put your answer as negative 4.25, and we could write f of negative 3 equals. Here I hope you wrote f of negative 3 equals 8, and here I hope you wrote f of negative 3 equals 6. Great job. All right, let's do the graph because the graph is going to be, like I said, the hardest. So let's grab our highlighter and let's go find x is negative 3. 1, 2, 3. There it is. And let's go ahead and move in an upwards direction towards the graph. That's because the graph is above that purple dot on my x-axis. I just have to figure out where the graph is to figure out if I move up or down from that purple dot. I'm going to move all the way till I get to the point, which is my answer right there. And then remember, I'm going to move to the y-axis by moving left or right because this number right here is my answer. This number right here is my answer, and it is positive 1, 2, 3, 4. So my answer here would be f of negative 3 equals 4.